Okay, so it sort of looks like we're still doing the same thing, but what do you notice about the equations on 31 that are different than the equations yesterday? Allie? Okay, we have variable terms on both sides. So that is going, Kayla, what is the problem? Somebody spray something?
Not me.
Okay. Okay, so just like yesterday, we need to first look for opportunities to distribute. Second, we need to look for opportunities to combine like terms. Okay, so that's kind of like A, B, right? First, we look to distribute. Second, we look to combine like terms. Okay. Then we want our variable to be just on one side. I don't want a variable on both sides of the equation. I want only on one side of the equation. So I'm going to ask that you move our variable to the left side. Okay. I want you to move your variable to the left side. Once we do those three things, distribute, combine like terms, move the variable to the left side, then you are going to be left with a two-step equation, just like what we were working with the past couple weeks, okay? Undo addition, subtraction, undo multiplication, division, okay? So now, however, we need to be on the lookout for not only do we need to distribute, do we need to combine like terms, but do we have variables on both sides to where we need to move one of them over, okay? So look at number one and draw your fence. Right? Why are there two variables? Okay. So I always want you to first look for, are there parentheses where I need to distribute? I see 0 parentheses, so that one's done. Okay. We do not need to distribute. Do we have anything on the left that we can combine like terms?
Yeah. No. No.
I cannot combine 8x and 17. But one's a variable, one's not. Okay. What about on the right side? Are there any like terms to combine?
No.
Okay, so that's nice. 2 steps out of the way. Okay. Well, now I have variables on both sides. So we need to move our variable to the left side. So on the right side, we have this 2x. How is it attached to that right side? 2 is being multiplied to x, but 2x is being added to 35. So how are we going to undo? Yeah, we are going to need to subtract 2x. We're performing the inverse operation. Since 2x is being added to 35, we are going to subtract 2x from both sides to undo it. Okay, so do you notice that I want you to do the same thing I'm doing? I put minus 2x. I stacked my x's vertically. Did you do that also? Yes, that's going to help you stay organized. Okay, so what is 8x minus 2x? Okay, we still have our plus 17. We will always have this equal sign. What happens here? Okay, the 2x minus 2x cancel each other out, but we still have our positive 35. All right, now this is like what we were working with last week. We now have a two-step equation. Okay, Cash, what do we do next?
We subtract 17 on both sides.
I love it. We need to undo the addition. by subtracting 17 from both sides, he says. We do something to one side, we got to do it to the other side. So the whole point is for those to cancel. We still have our 6x. Oh, I need your help. Oh, what is 35 minus 17? 18. Jacob, what's our last step?
Divide 6 by 6.
All right, 6 is being multiplied to x, so we need to undo it by dividing both sides by 6 to get everybody.
3.
Tony, are you okay with 3?
Yeah, I actually said 18.
Because you wanted to say 18 divided by 6 equals 3. That's what you're saying. Okay. All right, how do you feel about that? That like wasn't that bad, right?
Yeah, it actually really was bad.
It was bad? Okay, well, we better do another one. Emma said it was bad, we better do another one. What's the question? Distribute means if we have parentheses, then we have to multiply through.
We should do this one. And do this one. That one's the
Mhm.
This one was okay. This one ending.
We'll do one of those, I promise. All right, let's do number 2. All right, friends. What is your question? Glad I could help. All right. Do we have any parentheses where we need to distribute? Boo. All right, boring. Okay, let's look at our left side. Does our left side have any like terms? Okay, does our right side have any like terms? Okay, so we actually do not need to combine like terms. However, we have variables on both sides, so we need to move our variable to the left side. I don't know what to do. What do I do?
Subtract 2k from
Okay, this is a positive 2k. So to undo it, we need to subtract 2k from both sides so that these two can cancel out. Yeah, but it was so bad. Notice how I'm stacking the minus 2k underneath my 7k. Underneath my 2k, so I can see that those are going together. All right. Caesar, what happens when I take 7k minus 2k? 7k minus 2k. Yeah. So we have 5k. This plus 8 is still here. My equal sign never goes anywhere. These guys go away. These guys go away. What's on my right side?
That was correct.
That minus needs to stay. Only the k is canceled out. That minus is still there. So it's a negative 37. Okay. All right, Wes, what do we do next? So if I add 8, is that going to undo this guy? Okay, let's subtract 8 instead. We're going to subtract 8 because we need to undo the addition. Negative 37 minus 8. Thank you, Kale. Negative 45. Okay. Ruby, what's our last step? Okay. We need to undo our multiplication by dividing by 5. K equals what?
Let's go.
All right. You guys are such rock stars. Why don't you do number 3 by yourself? What? You got it. I believe in you. So in the second one, we like subtracted the 2K from both sides. So in this one, what do we do? 9, 10. Make sure the n is the 2K. So that is a 1 in front of the m. So you have 1m minus 9m. That's exactly what I just did. No. So if this is +3, why are you adding 3?
I'm in the. You were needing.
Well, meant to.
What it's still gonna be. That's fine.
-16.
Oh.
It would, did you minus 9m? So it'd be a negative 8. This is
Oh, wait, wait, I still
So then,
All right, Emma, did you check to see if other people at your table got the same answer as you? Did they? Yeah?
no, I didn't get the right answer.
Oh, shit.
I got -2.
Oh. Okay, so some people are getting 2, some people are getting -2. Is that what I hear?
I didn't give them
It's -2.
divide by. Wait, hold on,
Okay.
wait. I messed up.
So, all right, do we have anything to distribute? No. Do we have any combined like terms? So if we move the variable, okay, Jacob, what was your first step?
To do what?
I'm asking you, what was the first thing you did?
-9.
So he minus 9m on both sides, okay? Which is, I think, what most of you did. Now, this is, remember, like a 1m. So 1m minus 9m is -8m. We still have our +3 equals -13. Okay, Kaden, what's next?
Then we -3 from both sides.
Okay, so we still have -8m, our 3 minus 3 cancels, and we have -16 over here. Here is a mistake that I keep seeing. Can everybody look up here? What number is being multiplied to m?
-8.
Did you say a negative with that 8? So when we undo the multiplication and we divide, we better to be dividing by the -8. So this becomes a +2. Okay,
I didn't know about the -8. I did it by 16. I did.
okay. So just be really careful with your negatives because that's just a really silly way to lose points on a quiz or test. Okay. All right. What I want you to do is turn the page and we're going to look at number 9.
Number 9.
Number 9.
Oh, crap.
Oh,
It's not that bad.
Okay.
We get to combine the like cheese.
See, that's it. So do you see parentheses?
Oh, man.
Okay. So I am not going to worry about distributing because we're not going to need to do it. But we do have some like terms on the left side. So this is what I'm going to do. I'm going to put boxes around my -5x and my +3x, and I'm going to circle my -16. Because on the left side, I have 3 terms. That's more than I need. I need to combine the ones that are alike. Okay, so negative 5x plus 3x.
Negative 2x.
And that minus 16 just stays at minus 16. So I have negative 2x minus 16, okay? I have not moved across the fence. I have only taken the left side of the fence and made it simpler. Okay, hold on. Is there any way to simplify the right side? Are there any like terms to combine on the right side? No, the right side has its life together. Okay, the left side, we had to help get organized. Okay. So now, who said they had the next step? Kale? Okay, we need to move the variable to the other side. So since we are in this problem, subtracting 9x on the right side, we need to add 9x to both sides to undo it. Now notice how I'm stacking my x's vertically. There's no reason for that. Okay. All right, so my 9x's are gone. Ooh, minus negative 2x plus 9x is 7x. I still have my minus 16. My 9x's cancel, so I'm only left with negative 23 over here on the right side. Okay. Madison, what's our next step? Good, we need to undo our subtraction by adding 16 to both sides. Okay, the minus 16 plus 16 are going to undo each other. Okay. We have our 7x. What do we have over here? Negative 7. That is awfully convenient, right? Because our last step, Sophia Peterson, is to do what? Okay, we need to divide by 7. So that Tony man, negative 7 divided by 7 is?
Oh, -1.
Negative 1. A negative divided by a positive gives us a negative.
What about?
Okay. I'm sorry that you thought that I.
It sounds like
All right, one more problem. Are you ready? We're gonna go to 14.
I called it.
14, really?
Yeah, I said it.
Yeah, I see that.
Yeah, he did. He got
All right, now, I do have these written up here for your reference. Step number 1 is to distribute. Do we actually get to do that? We haven't gotten to do it all day. I'm so excited. Okay, so please be careful when you distribute. Okay, I have parentheses, so this negative 6 gets multiplied to both. What is negative 6 times n? Negative 6n. But be careful. Negative 6 times minus 3 is a positive 18. Negative times a negative gives us a plus. That's why I chose this one, to make sure we talked about that, okay? Now let's do the distributing over here. We have 5 times 4, 20. And we have 5 times minus n. Okay, so we have the minus 5n. All right, we got the distribute.
I'm done with this.
We add the 5
You
and
add the 5 cents.
Okay, so do we have anything on both sides that we need to organize more? Okay, we do not have like terms that we need to combine. So yes, you are right, Cash. We need to take this minus 5n and we need to move our variable over. So we are going to add 5n to both sides so that all of our n's can be on the left. What'd you say? Okay.
-1.
I done did chat.
Can somebody answer Austin's question? Would it be -1n?
Yes.
It would be. So would you like me to write it as -1n? Okay. So -1n, we still have our plus 18, we still have our equal sign, 20, and then our 5 n's are gone. Okay, so we need to undo our addition by subtracting 18 to both sides. Is that what I heard? Okay, so you're telling me that on the right side, I would have 2. And on the left side, I had -1n. Okay, so Reagan says, I'm not done. We have to divide by -1. Do you agree with Reagan?
Yep.
That's good, because she's right. Nice work. We need to divide by -1 to undo that multiplication because we need n by itself. That negative is not okay. So we end up getting n equals -2. Dang, he thinks it's easy. Okay, well, here's the deal, bro. Page 33 and 34, I want you to do numbers 1 through 9.
33, 34.
Yeah, let's go. Let's get to it.
Wait, 1 through 9?
Yeah,
How much time do we have?
12 minutes. You can get a lot of problems done in 12 minutes, I feel. Yes, go for it.
Bro, I'm not.